Hello everyone, welcome back to the online classes. So in this video, we will solve some problems based on the density of the solids. So first question, copper crystallizes into a FCC lattice with edge length 3.61 into 10 raised to minus 8 centimeter. Show that the calculated density is in agreement with its measured value of 8.92 gram per cubic centimeter. So here they have given the copper will crystallizes in FCC lattice having the edge length 3.61 into 10 raised to minus 8 centimeter. Now we have to calculate the density of this copper, and after getting the answer we have to see that whether the value that we obtained is in agreement with this given value, that is 8.92. Means our answer should be near to this value. So now first write down what they have given. So the edge length of copper is denoted as A is equal to 3.61 into 10 raised to minus 8 centimeter. So this is the edge length, and it will crystallizes into FCC lattice. So if FCC lattice is there, then the number of particles in FCC lattice, that is represented as Z, is equal to 4. And we know to calculate the density of the solid, we have the formula D is equal to Z into M divided by A cube into Na, where Z is number of particles, M is molar mass, and A is edge length, and Na is Avogadro's number. So here Na, its value is a constant value, that is 6.022 into 10 raised to 23. And another value that we have to substitute to get the density is molar mass or atomic mass. And atomic mass of copper is 63.5 grams per mole. So these are the things that they have given in the problem. Now we have to substitute these values in the given equation, and then we will get the density, and we will see whether it is in agreement with its measured value or not. So first Z, that we know, that is equal to 4 into capital M means atomic mass, that is 63.5 divided by A cube. A cube means here A is 3.61 into 10 raised to minus 8 whole cube into Na is 6.022 into 10 raised to 23. Now 4 into 63.5, how much we will get? 254 divided by here 3.61 into 10 raised to minus 8 whole cube, that we have to calculate, and here 10 raised to minus 8 cube is nothing but 10 raised to minus 24. Simply we will multiply 8 into 3. So minus 8 into 3 is minus 24, and 3.61 cube will gives 47.04 into 6.022 into 10 raised to 23. So now if we multiply these two, we will get 254 divided by 283.3 into 10 raised to minus 24 plus 23 will gives minus 1. So now divide these two, 254 divided by 283.3. How much we will get? we will get 0.896 into 10 raised to plus 1, because if it comes to numerator we will get 10 raised to plus 1. So simply 0.896 into 10 raised to 1 means 10, we will get 8.96 gram per cubic centimeter. So now this is the density of the copper. So if we observe the density of copper that we have calculated and the density of copper that they have given, that is 8.92. So they are very close to each other, and hence we can say that the calculated density is in agreement with its measured value of 8.92 gram per cubic centimeter. So this is how we will calculate the density of an crystal. Now we will move to the next question. The gold atomic radius is equal to 0.144 nanometer, crystallizes in a face-centered unit cell. What is the length of a side of the cell? So the length of the side of the cell means we have to calculate the edge length. So in order to calculate the edge length, we have to know the value of R. Here which formula we are going to use? We will not use the density formula. First write down what they have given. Gold will crystallizes in FCC and we have to find the length of the side of the cell. The atomic radius, that is denoted as R, is equal to 0.144 nanometer. So it will crystallizes in face-centered unit cell. What is its edge length? Here we simply use the relationship between the edge length and radius in case of FCC. So that relation between A and R in FCC is given as A is equal to 2 root 2 into R. That is the standard relation. Now substitute the value of R here, that is radius. So 2 into root 2, that is 1.414 into 0.144. So how much we will get? On multiplication we will get 0.407 nanometer. So this is the edge length of the gold. So whenever they will give the radius of an atom and asked you to calculate the edge length, then we have to use the relationship between A and R. Here in case of FCC, the relation is given as A is equal to 2 root 2 R. And if they have given SCC, the relationship between A and R is given as A is equal to 2R. And in case of BCC, the relation is given as A is equal to 4R divided by root 3. So remember these relations, okay? The simple questions, they may be asked in the examinations for 2 marks, okay? Now next question. Aluminium crystallizes in a cubic close packed structure. So its metallic radius is 125 picometer. Then we have to find what is the length of the side of the unit cell and how many unit cells are there in 1 cubic centimeter of aluminium. So again, here first thing we have to calculate the edge length, and they have given radius, that is equal to 125 picometer. So in order to calculate the edge length, we will use the relationship between A and R. So A, here in the first case we have to determine A. So A is equal to CCP, cubic close packed structure, that is nothing but FCC. So thus the relationship between A and R is given as A is equal to 2 root 2R. Now substitute the value of R, that is 2 into 1.414 into R is 125. So how much we will get? It will be 354 picometer. Now how many unit cells are there in 1 cm cube of aluminium? Suppose if we take 1 cm cube of aluminium, how many unit cells are there? That we need to calculate. So first we have to calculate volume of unit cell. So if we take the unit cell, ratio of unit cell to the total volume of the unit cell, we will get the number of unit cells present in 1 cm cube. So here simply first find out volume of unit cell. How to find the volume of unit cell? That is nothing but A cube. So here A is 354 picometer. Now I will simply convert this picometer into centimeter so that the calculation would become easier. So I will convert this into centimeter and I will make it 3.54 into 10 raised to minus 8 centimeter. So now take the cube of this value 3.54 into 10 raised to minus 8 centimeter cube. So 3.54 into 10 raised to minus 8. As we know, 10 raised to minus 8 into 3 is 10 raised to minus 24. And 3.54 cube will give 44.36. So now this is the A cube. Now we have to find the number of unit cells in 1 cm cube. Number of unit cells in 1 cm cube is equal to how much volume they have given? 1 cm cube given volume to the total volume, that is 44.36 into 10 raised to minus 24. So upon simplification, how much we will get? So simply try to calculate this. 1 divided by 44.36, that will give how much? 0.0225 into 10 raised to 24. Okay, so or you can else shift the decimal point, then what you will get? 2.25 into 10 raised to 22. 2.25 into 10 raised to 22. So this much number of unit cells are there in 1 cubic centimeter of aluminium. So this is the another type of a problem which can be asked you to calculate the number of unit cells in the given volume of the crystal. The next question. Niobium crystallizes in body-centered cubic structure. If density is 8.55 gram per cubic centimeter, calculate the atomic radius of niobium using its atomic mass 93U. So here they have asked you to calculate atomic radius. So in order to find the atomic radius, first we have to calculate the edge length of the unit cell. So once if we get the edge length of the unit cell, then we can easily calculate the atomic radius, because we know here the body centered cubic structure is given. That means the A and R can be related as A is equal to 4R divided by root 3. So in order to find r, what we have to do? R is equal to root 3 into a divided by 4. So if we substitute the value of a, we will get the value of r. So therefore, first we have to calculate the edge length. Now how to calculate the edge length? First, write down the given things. Density is given, that is 8.55 gram per cubic centimeter. And it will crystallizes in body centered cubic structure. So Z is equal to 2. Z means number of particles in BCC. And atomic mass is also given, that is 93 U. Now we have to find the edge length, that is A. And Avogadro's number that we know, that is 6.022 into 10 raised to 23. Now we have the formula D is equal to Z into M divided by A cube into Na. But we know the density, but we don't know the A cube. So simply cross multiply this. What we will get? A cube is equal to Z into M divided by D into Na. Now substitute the values. A cube is equal to, so Z means 2 into M is 93 divided by density is 8.55 into 6.022 into 10 raised to 23. Now if we simplify this, we will get 3.61 into 10 raised to 7. So simply multiply 2 into 93 and then 8.55 into 6.022. Then divide these two, we will get 3.61 into 10 raised to 7. That is the value of A cube. But what we want? We want A. So in order to find the A, we have to take cube root. So cube root of A is written as 3.61 into 10 raised to 7 1 divided by 3, that is cube root. And here I will make some small modifications. Here instead of writing 3.61, I will take 36.1 into 10 raised to 6 raised to 1 divided by 3. So here simply I have shifted the one decimal point to the right side. So here it will become 10 raised to 6 into 1 by 3. And here 10 raised to cube root of 10 raised to 6 is 10 raised to 6 into 1 by 3 we will do. So 3 ones are 3 twos are. That will gives 10 raised to 2. Okay. And here 36.1 cube root. How we have to calculate that? Here we can calculate by taking the log. But the convenient method that is used to calculate the cube root by using simple calculator is, what we have to do is, we have to take simple calculator and simply first we need to enter 36.1 because we want the value of cube root of 36.1. So after typing this 36.1, we have to press the square root sign 2 times. We have to type first 36.1 and we have to type this square root 2 times. And after clicking this square root 2 times, we have to multiply. Means we have to press the multiplication sign. Again, after that, we have to press the root key for 4 times. First we have to click it for 2 times, then multiply, then again click the square root by 4 times. And again we have to multiply, and again we have to type the square root 8 times. So when we press the square root 8 times. Again we have to press the multiplication sign in the simple calculator. So first we have to type 36.1, then square root 2 times into square root 4 times into square root 8 times, and finally press the multiplication sign. So if we do this, then we will get the cube root of 36.1 or the any value that we want to find the cube root. So 36.1, if we follow this rule, we will get the answer as 3.304. So cube root of 36.1 is 3.304 into 10 raised to 2 picometer. 3.304 into 10 raised to 2 picometer. Or we can also write it as 330.4 picometer. So this is how we will find the cube root of A. Now they asked you to calculate atomic radius. So use this formula and substitute the values. That is root 3 into A is 330.4 divided by how much? 4. So if we simplify this, we will get the answer. That is square root of 3 is 1.732 into 330.4 divided by 4. So simplify this. On simplification, how much we will get? 143.06 picometer, or we can say 143 picometer. So this is how we will find the radius when they have given the density, atomic mass as well as the number of particles. We have to first calculate the A cube, then we have to take the cube root of A, and after that we have to use the relationship between A and R. Upon simplification we will get the answer, that is radius is equal to 143 picometer. So the important thing is remember how to calculate the cube root, because in examination they won't allow scientific calculators, only simple calculators are allowed. So by using simple calculator, by using this technique, we can find the cube root. So remember this technique. So this is all for now. We will solve some more problems on solid state in next video. Thank you.